So we have now around 41. So, okay, let others join so that we can start. So we were discussing about projectiles in the last class. Okay, na? Projectiles. So let's continue that. We have seen all these things, the solution of vectors, acceleration we have seen, then these questions we have solved last class. Then projectiles. So what is a projectile? It's a device, so it's an object which is thrown in space, and the only force which is acting on this one is the gravity, this projectile motion. All these things we have seen. Okay. See the equations we have derived: time of flight, horizontal range, then maximum height. All these things we have derived, and we have solved a few numerical problems also. Now we are going to see circular motion. So can you find some examples of circular motion from our immediate surroundings? Some examples of circular motion. Can anybody tell me an example of circular motion?
Merry-go-round.
Solar system.
Yeah, solar system, movement of
Revolution of
planets
Earth.
around the sun, then merry-go-round, and all these things. See, in this case, in the case of circular motion, basically we can say that it is a kind of motion which is restricted to the circumference of a circle. Okay, there will be a circle. Okay, and the velocity at this point will be like this. This is the velocity vector. It keep on changing. So here the velocity vector will be like this, and here the velocity vector will be like this. Always the velocity vector keep on changing. It will always be the tangent to the curve. It always keep on changing, we can say. Okay, all right. So when you take a stone tied at the end of a string, and when you rotate it above your head, you will have the same picture, but you will experience a force in your hand. You will experience a force in your hand. Can anybody tell me the reason why you experience a force in your hand? When you take a stone tied at the end of a string and rotate it above your head, your hand will experience, your fingers will experience a small force. What is the reason?
Acceleration.
There will be an acceleration, and always the stone which is tied here, the stone which is tied here, it will try to escape. Yeah, centripetal force. It will try to escape. Always it is trying to escape, and your hand is holding it towards the center. So there is a force which is always trying the stone to escape. That is called centripetal force. Centripetal force, Fc. Okay, Fc will be equal to mv square by r. Centripetal force is equal to mv square by r. All right. So because of the centripetal force, it is not falling down. Otherwise, it will fall down. When you are rotating it, this will have centripetal force, and the centripetal force will be balancing the weight, and it will be rotating like this. The interesting thing we have to remember here is, for everything which is rotating, it will have the centripetal force. Whether it is in the vertical plane or in the horizontal plane, it will have the centripetal force, and the centripetal force is towards the center. Okay, it is towards the center. Right, velocity will be always tangent. Okay, so here the force is towards center. This is centripetal force. Velocity is tangent. So the angle between these two will be velocity and acceleration. Angle between
90
velocity and, yeah,
degrees.
90 degrees. They are perpendicular. So in the case of circular motion, the force is always towards center, the acceleration is towards center. See, Fc equals mv square by r. Okay, so acceleration there is v square by r. This acceleration is known as centripetal acceleration. Acceleration known as centripetal acceleration. Okay, so in the case of circular motion, acceleration is towards the center. Acceleration of the body is towards the center, and velocity is tangent to the circle. So velocity and acceleration are perpendicular to each other. Now, see the vectors of velocity and acceleration. See, in this case, the velocity vector is like this. We can represent like this, the velocity vector. After some time, the velocity vector changes like this. Okay, so after some time, we can write the velocity vector to be like this. And when we take the vector sum, v1 and vi, v initial and v final. So v final is like this. This is v initial and this is v final. V initial and v final. This is the difference in velocity delta v. Okay, difference in velocity delta v. As per the triangle law of addition of vectors, we can mark the delta v, the difference in velocity, like this. Now come back. Consider the motion of a body in a circular path with radius r. So radius of this path is r. Then velocity over a complete cycle. We define velocity as the distance divided by time. Okay, over a cycle, velocity will be equal to total distance. How much will be the total distance over a complete cycle if the radius is r? If the radius is r,
2 pi
what will be its total distance traveled? It will be 2
pi
pi
r.
r
2 pi 2 pi
divided
r
by time. Divided by time. Okay.
2 pi r
2 pi r.
Yeah, 2 pi r. 2 pi r. So divided by time. And this time taken to complete one full round. This is called time period. Time period. Okay. Time taken to complete one full cycle. Time taken to complete one full cycle. That is called time period, capital T. Capital T. Okay. So we can write it as 2 pi r divided by capital T. So this is written here, 2 pi r divided by capital T. When 2 pi by t, we call it as the angular velocity. Angular velocity. There is a reason for that angular velocity. You might have heard about radians. What's your idea about radians? Tell me your idea about radians. What do you know about radians? Radian. Are you hearing the term first time? No idea about radian?
No.
Either say yes or
For
no.
measuring angle.
Yeah, for measuring angle. Okay, right. And then any other? Are you
It's an angle subtended by the arc which have the same length as radius.
which one? Which one? Angle subtended by an arc. Very good, very good. Who is that?
Anju Saji.
Okay, fine. So angle subtended by an arc.
1 radian is equals to 180 by pi
180 by 3. So this is an arc. Subtend an angle. Okay, now we need some basic fundamentals about radian. So there is a circle, degree and radian. Let's see. So what is the total angle in the case of a circle? Total angle.
360
Total angle equals 360 degree. Okay, this will be termed as 2 pi radians. 2 pi radians. Okay, na? So
360 degree.
how do we get this 2 pi radians? What is the circumference?
2 pi r.
2 pi r divided by r. How much it will be? 2 pi. Now what will be 180 degrees? 180 degrees.
Pi.
5 radian.
Pi
Pi.
radians.
Pi radian.
Then 1 degree. 1 degree.
1.
180 by pi.
5 by
5
180.
radian by
5 by
180.
180 radians. 5 by 180 radians. Similarly, 1 radian equals
180 by pi.
180 by pi degrees. Okay, now? Okay. So this is the conversion. So for calculations and all these things, now onwards we will take radians only, not degree. We will take radians only because we get in digits form. Here in degree only we get. Here it is in digit form. See, 2 pi radians, that is 2 into 3.14. In digits form we get it. So it is easy for calculations. Okay, again we have to convert this and all. It will be complicated issue. So here onwards we will take all these measurements of angle in radians only. Is it okay? So remember, total angle is 2 pi radians. So 180 degrees pi radians, and 1 degree equals pi by 180 radians. Okay. Now you see this one once again. So radian, it is clear now. So we can take V equals R omega. Omega is the angular velocity. Omega is angular velocity. So total angle turned in one complete cycle is 2 pi. Total angle turned in one complete cycle is 2 pi. And the total time taken for that is capital T. So 2 pi by T equals omega. See this one. Delta V by V, the change in velocity to original velocity, it will be similar to delta R by R because velocity equals displacement divided by time. Time is a fixed thing. So delta V by V will be equal to delta R by R. And we know that delta R, that is the displacement, will be equal to velocity multiplied by time. Displacement equals velocity multiplied by time. Then when we rearrange this, we get delta V by delta T. That is delta V divided by delta T will be equal to V square by R. So we bring it here, okay, and this delta T we bring it here. Okay, delta V by delta T will be equal to V square divided by R. We know delta V by delta T is the acceleration, and that is equal to V square by R. So this is why we write centripetal acceleration equals V square divided by R. Okay, once again, delta V by V, ratio of change in velocity to original velocity, will be equal to change in displacement to original displacement. Means, okay, then when rearranging this, we get V square divided by R. This is the centripetal acceleration, equation for centripetal acceleration. See, this acceleration will be always towards the center of the circle. Then the equation for force is equal to mass multiplied by acceleration. That will be equal to mv square by r. F equals mv square by r. Is it okay?
Yes, sir.
Yes, sir.
You are not speaking, only I am speaking. Now the summary of this lesson, let's see. Physical quantities can be classified into vectors and scalars. So those quantities which are having both magnitude and direction, we classify it as vectors. And only magnitude means scalar. This means both direction plus magnitude. This means only magnitude. Then I, J and K are unit vectors in X, Y and Z, whose magnitude is unity and their nodes are in directions. And what are the different methods of vector addition? Come on, tell me. Different methods of vector addition.
Angle law.
First one?
Triangle law.
Yeah,
Triangle.
triangle law.
Triangle, parallelogram,
Yeah, parallelogram.
Parallelogram. Polygon.
Polygon law.
Yeah, polygon. Can anybody tell me what is triangle law?
Head
Two
to
vectors
tail.
Yeah, come on.
in head to tail. Two vectors in head to tail form. Then their resultant would be the third side.
Yeah, very good. If two vectors can be represented as adjacent sides of a triangle, then the resultant will be the third side of the triangle taken in the reverse order. Okay, good. Then parallelogram law. Anybody? Parallelogram law of addition of vectors.
If two vectors are
Yeah,
positioned in a tail-to-tail position,
yeah,
then the diagonal of the vector will be it forms a parallelogram.
yeah. Then resultant will be the
Diagonal of the
yeah
parallelogram.
resultant. Can you tell me the equation for resultant? Resultant R will be equal to root of a square plus b square plus
B
2a b cos theta. Marno? A square plus b square plus 2ab cos theta. So that is the resultant equation. Then if theta is 90, if theta equals 90, then r will be equal to root of a square plus b square. Okay, so that this is triangle law. this we can get parallelogram law. Then average velocity is dr by dt. Then acceleration is defined as change in velocity divided by time. Change in velocity divided by time. Then a projectile is an object which moves in space under the sole effect of gravity. Okay, sole effect of gravity. And there are three equations. Time of light 2v0 sin theta by g. Maximum height v0 square sin square theta by 2g. Horizontal range it is v0 square sin 2 theta by g. At what angle we have to project to get maximum range?
45 degrees.
Yeah, 45 degrees.
45 degrees.
Maximum range means 45 degrees. Alright, maximum range means 45 degrees. And maximum height
90 degrees.
90 degrees.
90 degrees. 90 degrees maximum height. Okay, then circular motion can be described as the motion of an object in a circle at a constant speed. Motion of an object in a circle at constant speed is called circular motion. Okay, and now you can ask your doubt. I'll show you some questions. Can you do these questions? You just have a look. Okay, don't worry, I'll send it to your WhatsApp. Question as well as answer. Solutions are also there. I'll send it to your WhatsApp. And we will have a discussion on this tomorrow. Okay, tomorrow we will discuss these questions. First, you see the questions, see the answers also, and we will discuss the questions tomorrow. Okay.
Okay, sir.
Now today we
Okay.
have only 60.
Sir.
Number of students are less. Only 60 students we have. We have one more chapter for the exam, term exam, and one rule came now. We should not take class more than 30 minutes a day. It's another thing. I don't know how we are going to finish the syllabus. Okay, fine. We will try our best. Okay, then. Thank you.
Thank you,
Thank
sir.
you. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.